Every second, thousands of drones take to the skies. But have you ever wondered how four small motors can lift an entire aircraft and keep it perfectly balanced in the air? Today, we'll uncover the engineering behind modern drones. A drone is much more than flying propellers. It is a complete engineering system where every component works together. Remove just one critical part, and the entire aircraft can no longer fly. Every drone is built from carefully engineered components. Each part has a specific job, and together they create a stable, intelligent flying machine. A brushless motor is the heart of the drone. Electrical energy creates a rotating magnetic field, spinning the rotor at thousands of revolutions per minute. This rotational force is what ultimately generates lift. A spinning propeller pushes a large volume of air downward. The air pushes back with an equal and opposite force. That upward force is lift, allowing the drone to leave the ground. If all four propellers spun in the same direction, the entire drone would spin uncontrollably. By making two propellers rotate clockwise and the other two counterclockwise, the rotational forces cancel each other, keeping the drone stable. To take off, all four motors speed up together. As their speed increases, they generate more thrust. The moment total thrust becomes greater than gravity, the drone lifts smoothly into the air. To move forward, the rear motors spin slightly faster while the front motors slow down. This tilts the drone forward, redirecting the lift force and producing forward motion. This movement is called pitch. To move sideways, the motors on one side spin slightly faster than those on the other. This causes the drone to roll, tilting the lift force and allowing controlled movement to the left or right. Yaw controls the drone's direction. By increasing the speed of one pair of motors and decreasing the opposite pair, the drone rotates about its vertical axis while maintaining the same altitude. The flight controller is the brain of the drone. Every second, it reads data from multiple sensors, processes the information, and adjusts each motor hundreds of times to keep the drone stable and precisely under control. Even when wind pushes the drone off balance, the flight controller detects the movement almost instantly. It automatically changes the speed of each motor, bringing the drone back to a stable hover within milliseconds. To know exactly where it is, the drone receives signals from multiple GPS satellites. By calculating the travel time of these signals, it determines its precise location, altitude, speed, and direction, making autonomous navigation possible. The electronic speed controller, or ESC, acts like the drone's power manager. It receives commands from the flight controller and precisely which electrical power reaches each motor, allowing smooth acceleration and accurate flight control. Every flight begins with stored energy. The lithium polymer battery supplies high current to all four ESCs, providing the power needed for the motors to generate lift. Battery capacity determines how long the drone can stay in the air. Every successful flight depends on perfect teamwork. The battery provides power, the flight controller makes decisions, the ESCs rate each motor, and it can flight. Together, they transform electrical power into intelligent aerial movement. The same engineering you've just learned powers drones across countless industries, from agriculture and emergency rescue to infrastructure inspection, filmmaking, mapping, and autonomous delivery. You've just learned the complete engineering behind drone flight. In the next episode, we'll open up a brushless motor and discover how electromagnetic forces produce thousands of revolutions per minute. This is where drone engineering truly begins.